this video on graphing an exponential function. This is going to be a basic, very basic function. However, the key ideas and the key understandings to graphing this one will apply to any exponential function that you fall into, or any function in general. If you never know how to graph a function, start by just choosing x values. Here I've chosen some x values, and you're going to just substitute those into our function. So we have a function f of x equals 3 to the x. So this is telling us we have an input and an output. So the first input that we're going to have is -3. Now -3 is going to go into our function that I have written over here. So I always have some side work to do, and I'm going to substitute -3 in for x. So now I have 3 to the -3rd, which gets a little bit tricky, but we know that we would want to put that over a 1 because it's a negative exponent. It's going to move. So it's going to move from the top to the bottom. So if I keep this left side the same, 3 to the -3rd is going to move to the bottom, and it's going to become 3 to the positive third, so that now we have 1 over 27. We're going to do the same thing for the next few. So we're going to now substitute in -2 for x. So -2 goes in for x, 3 to the -2nd, that's going to move to the bottom. It's going to become 3 to the positive second, so when it moves, the exponent's going to change. So when we simplify 3 to the second power, that's 9. So that's going to be 1 over 9. And we're just going to keep doing that. And we're going to keep simplifying it down. So 3 to the -1st becomes 1 over 3. And we continue on, and I'm just going to go ahead and complete the table. Remember, when we have 3 to the 0, that's going to be 1. So 3 to the 1st, 3. 3 to the 2nd, 9. 3 to the 3rd, 27. So we can also start using what we know about common ratios. We see this pattern. We're multiplying by 3 each time as we go down. So we can use that as well. So if we're going to plot some of these points, we obviously cannot plot all of them. We can plot some of them. So -3, 1, 2, 3. And then 1 over 27, that's just a tiny bit off that line. Very small amount. If we look at -2 and 1/9, like very small amount, but we're going up just a little bit. And then -1, 1/3. That one's a little easier to eyeball. 0, 1. 1, 3. 2, 9. 3, 4, 5, 6, 7, 8, 9. And that looks like the last one that we can do. So as we look to draw this, we would know it goes up very steeply, and it follows this curve. And this curve gets really, really close. If we extended this table up, and we kept going like -4, -5, -6, this number for the y value would keep getting smaller and smaller, or closer and closer to 0. So we would see that. So what we would do is, based on that, we have what we call an asymptote. So the value that it gets really, really close to, but it never quite touches. And so we use a dotted line to indicate that. And we would say that asymptote is at y equals 0.